Now let's look at all the trigonometric function derivatives all together. And we'll start by stating all of the derivatives, and then I'll look at the last four, the secant, cosecant, tangent, cotangent derivatives a little more in depth so you can see where they come from. But really this video is to serve as the derivatives of all the trigonometric functions. So we'll call this trigonometric derivatives. So we have the derivative with respect to x of the sine of x function is cosine of x. And over here we have the derivative of the cosine function is the negative sine function. Okay. Now let's look at the other four. And I'm organizing this way on purpose. So if you're taking notes, you may want to organize in a similar fashion because I'll point out some patterns. So next we have, let's look at the secant function, secant of x. The derivative of the secant function is secant x times tangent x. And then over here, I will look at the co-version. So instead of secant, I'll look at cosecant. And I always have trouble writing cosecant for some reason, even after all these years. Cosecant of x is negative cosecant x cotangent x. Okay? So maybe you're starting to see a pattern. What I'm doing here is I'm organizing all of the co-functions in this column. The derivative of all three co-functions will be negative outputs. Okay? The non-co-functions won't have negative outputs. Similarly, you'll start to see similarities between secant and cosecant. For example, secant is itself times the tangent function, while cosecant is itself times the cotangent function. So the co's kind of pair up here, and the non-co's kind of pair up here. All right, so next we have the tangent and the cotangent. So since tangent doesn't have a co on it, we'll put it in the first column. So the derivative of the tangent function is secant squared of x. So in other words, secant x times another secant x. And maybe you could guess what the derivative of the cotangent function is. You know it's negative, and in fact it's negative cosecant squared x. And so the tangent and the cotangent function output squares. The secant and the cosecant function output itself times one of the tangents. So secant outputs itself times the non-cotangent, right? Just the regular tangent. While cosecant outputs itself times the cotangent. All right, so you can pick up on the patterns. You can nail these down very quickly. You need to know those derivatives. Now, in a separate video, I talked about why the derivative of the sine and cosine functions are what they are. Now what I want to do is explore each of the other four derivatives using what we know about sine and cosine along with the quotient rule. Okay? So I'll assume you've seen the quotient rule already. So let's see where to start. We'll start with, let me recopy these four over here. And actually, I probably won't do all four of these. I'll probably just do maybe just a non-co. So maybe I'll do secant, and then I'll do one of the co's. So maybe I'll do the cotangent. Okay. So let's focus on those two, and you could apply the same concepts to the other ones. So I'll copy the two we're going to focus on here. So we're going to look at the derivative of secant, and we're also going to look at the derivative of cotangent, which is negative cosecant squared. Okay? All right. So let's look at these and see how we can show that those are the derivatives. So let's begin with the derivative of the cotangent function and see what happens here. So the derivative of cotangent of x, well, I can rewrite cotangent as cosine of x over sine of x. You should know that from trigonometry. So derivative of cotangent is the same thing as cosine over sine. And the reason that's useful to us is because we already know the sine and cosine derivatives. Those are, we're building on those. And the other thing we know is that this is a quotient. So we're going to use the quotient rule to get this derivative. So the quotient rule says you take the bottom, sine of x, times the derivative of the top. The derivative of cosine is negative sine of x. So the bottom times the derivative of the top minus the top times the derivative of the bottom. The derivative of sine of x is cosine of x. Okay? And that's all over the bottom squared. So sine squared x. So what we end up with is negative sine squared x, right? When you take sine times negative sine, you get negative sine squared, minus cosine squared x over sine squared x. All right? And again, this will be a review of some trigonometric identities. You notice the top, you've got sine squared and cosine squared, and there's a very nice identity that deals with that. The problem is we've got negatives here. So what we'll do is we'll factor a negative 1 out, leaving positive sine squared x and positive cosine squared x. And all of that's over sine squared x. Now hopefully this binomial in the parentheses looks familiar to you. Sine squared x plus cosine squared x is my favorite trig identity. It's called one of the Pythagorean identities, and sine squared x plus cosine squared x is the same thing as just 1, which is fantastic. So we end up with negative 1 over sine squared x. Well, that's precisely what negative cosecant squared x is. Remember, cosecant is 1 over sine. So 1 over sine squared is cosecant squared, and we've got the negative. So we can see that the derivative of cotangent is negative cosecant squared. All right? Now, something else to kind of help you relate things, I want to give you as much as you can here to relate all of this, is remember that this formula tells you the derivative of cotangent. So this formula tells you how to calculate the tangent line slopes to the cotangent curve. Now, let me say that one more time. When you find a derivative, the formula that you get tells you how to calculate the tangent line slopes to this curve, which in this case is the cotangent curve. Now, if you recall the cotangent curve, it looks something like this. It has a bunch of asymptotes, right? All these asymptotes. In fact, the y-axis is an asymptote. But it does this kind of thing. And it just repeats. It's periodic. And it goes on forever in both directions. So I can't graph it all. But what you'll notice is, no matter where you look at the tangent line on this curve, it's got a negative slope. You see that? The tangent line always has a negative slope. And if you think about this expression, cosecant squared, when you square anything, you're not going to get a negative. So this guy right here, I'm going to label it as positive, but it's really not negative. It could be 0. Actually, it can't be 0 for trigonometric reasons. But so this guy's positive because it's squared. But then you multiply by a negative, and so you get a negative answer for any derivative, or for the derivative of cotangent, no matter what x is. You get a negative answer. And you can see that that's because every tangent line to the cotangent function has a negative slope. So that can help you maybe make some other connection between this cotangent function and its derivative, negative cosecant squared. But here's the algebra behind it using the quotient rule. Okay? Let's do the same analysis on the secant function. Same idea. You can even, I'd encourage you to pause the video and try it yourself. There's no secret. We're going to be using the quotient rule. Of course, the first thing you have to remember is how do we write secant as a quotient, right? So you need to remember your trigonometry here. I've been stalling in hopes that by now you've thought of how to write secant as a quotient. Well, secant, by definition, is the reciprocal of the cosine function. Okay? And this quotient rule actually is a little bit easier than the one we just did. You do the bottom, cosine of x, times the derivative of the top. Well, 1 is a constant, so its derivative is 0. So cosine of x times 0 minus the top, 1, times the derivative of the bottom. Well, the derivative of cosine of x is negative. It's a so its derivative is negative sine x. And it's all over the bottom squared. So cosine squared x. Of course, this guy, cosine of x times 0, just turns into 0, right? No big deal there. And so what remains is we've got negative 1 times negative sine x, so that's positive sine x, over cosine squared of x. And if we rewrite that using our trig functions, well, I've got a cosine squared on the bottom. So what I'll do is I'll rewrite that as 1 over cosine of x. And that leaves behind sine x over cosine x, kind of splitting the fraction apart into recognizable trigonometric functions, right? You can see that this product is the same thing as this quotient. And so what we get here is 1 over cosine of x. Well, that's just secant of x. Times sine x over cosine x is just tangent of x. So the derivative of the secant function is secant times tangent, okay? So you could try the other two remaining derivatives on your own. They're virtually the same. You might have some minuses floating around in there, right, that you may have to play around with. But it'd be a great exercise to practice your trigonometric identities, practice your quotient rule, and practice your derivatives of sine and cosine, because they show up in all 4 of those functions.